All right, welcome back to more smart contract vulnerabilities. This time we're looking at the unchecked call return values. And this is one of those things where you just got to understand the built-in methods you're using and the differences, the nuances between them. So the gist of this is you want to be using the transfer method in most cases when you need to, like the name would imply, make any kind of transfer, like a payment to an address. It's possible to use the send function, but they behave differently. So if you use the send function, then you have to check for the result. And if you don't validate that, it can result in some pretty devastating bugs for an end user. So let's just get right to it. Basically, the transfer method and the send method are two ways to, send or transfer your Ethereum from one address to another. Now, or whatever, not necessarily Ethereum, right? It could be whatever cryptocurrency was built on top of it or whatever, right? You're sending funds, let's just say, from one address to another. So there's a call opcode that can be directly employed in Solidity. So call and send, they return a Boolean indicating if the call succeeded or failed. Okay, that's the important distinction, because with the transfer, there's actually like a fallback, if you will. I believe that's the term for it. If it fails, it'll actually revert, right? It will revert. Call and send will not revert. They basically only just return a Boolean indicating if it succeeded or failed. So when you're writing your code in Solidity, you need to make sure you're checking for these return values and you're validating, you're making sure that you're only going to move to the next step if that Boolean returned true, because what you don't want is for the send to fail for whatever reason and the program just keeps moving forward assuming someone got paid when someone didn't get paid. Someone's going to be pretty mad, right? And rightfully so. We'll see an example of that. Ooh, man, it's painful to read, but we'll see an example of that here pretty soon. So here's what the vulnerability looks like in code. And before I get here, I just thought this was really interesting. This link here, the DASP top 10. So, I'm sure a lot of viewers on this channel watching this video right now are familiar with the OWASP top 10. This is basically the DApp version of it, right? For, the decentralized apps, right? Decentralized Application Security Project. So basically there's a decentralized version of OWASP, basically, with no affiliation to OWASP, I don't think. But NCC Group is behind this. But they have categorized the top 10 vulnerabilities. This list is as of 2018. So this is the DASP top 10 of 2018, and reentrancy was number 1, and that was a vulnerability, the first one we looked at in this series. Access control, arithmetic issue, so your integer overflows and underflows, we looked at that as well. And then this is the one we're looking at right now, unchecked return call values for low-level calls, denial of service, bad randomness, yep, we talked about that one. Front running, which that's actually, I believe, the next topic we're going to cover in this video series. And we have time manipulation and the short address attack. We cover that one. And then unknown unknowns. So, I just thought that was pretty interesting. Wanted to give that a special shout out. You guys can check that out on your own if you'd like. Let's look at the code, though. This is the code that where this demonstrating the vulnerability, right? So if we have a contract called Lotto to basically pay out a winner and allow the leftovers to be withdrawed afterwards. We can see here there's a function send to winner, and you're just running a winner.send, and then after you send the earnings to the winner, we're simply setting the paid out variable to true. We're not actually performing any kind of check to make sure that this send, to validate that this send processed correctly. So if there was some kind of error with the send, like say he didn't have enough in his wallet to cover the Ethereum gas fee, then the send would fail, right? And this program has no way of knowing that the send failed because, as you see here, with the withdrawal leftover function, it's just simply doing message sender send this dot balance, and nowhere in any of this code is it validating the return call that it's true instead of false, right? Because if the send fails, it's going to return false, but we're just not checking for that in the code anywhere. And so that's basically where the vulnerability lies, right? And that's basically what they're talking about here. Regardless of whether it was sent or not, it's just going to keep moving forward. And so what you can do is basically purposely make it fail, and then the amount left over is literally the entire amount because nothing was sent. So all of this is here, and then you can just have it send everything. So that's basically how the vulnerability works. And now, as far as how to prevent this, like I was saying earlier, we just need to make sure we're checking for that return value. So if it does fail, remember it returns a Boolean. So if it succeeds, it returns true. If it fails, it returns false. So we can just check for that in our code. And but really, to be honest, the better way is to use transfer, because then you won't have to do that, right? Whenever possible, use the transfer function rather than send. Transfer will revert automatically, right, if the external transaction reverts. So you shouldn't really use send unless there is a specific reason to use send over transfer. So in these scenarios, they're probably better off using transfer, and they wouldn't have to worry about that all together. So for the real world example, there was Etherpot and King of Ether. So there's a couple examples here, really. But yeah, if we're looking at this code here, we can see this cache function, and this is just a snippet of the code. And basically, based off of some conditions, it's gonna return, right? So if subpot index is greater than or equal to subpot's count, if this doesn't matter the conditions, right? You have 3 different conditions here, and they're gonna return. And you see down here, winner.send subpot, and nowhere in this code anywhere is it actually checking. Is it actually checking the send, right? It's just performing the send. It's not checking if it processed correctly or not. It's just moving forward. So see, if you notice, and these line numbers are not correct, but it says, if you notice this, the sends function return value is not checked, and the following line sets a Boolean indicating the winner has been sent their funds. Yeah, that's another part that's really important, right? The following line that sets a Boolean indicating that the winner has been sent their funds, but they don't even know if the winner has set the funds. They just hard-coded that in there. So you see this here, right? Round index is cached, subpot index equals true. So they're just saying, hey, he got his money, but they didn't actually verify that. That's just automatically what happens next in the code. It's hard codes it to true. So yeah, don't do this, guys. So, and then apparently a more serious version occurred in King of Ether, which basically there's a article that details how an unchecked failed send could be used to attack the contract. So that's another one. And yeah, this one goes pretty in depth on that. I'm not going to go through this whole thing here, but yeah, kingovether.com, postmortem.html, if you want to check that out. You can see it with a lot of detail. But that is the unchecked return call values. Let's go back there. And in the next episode, we will be looking at, like I said, race conditions, front running. So that was one of those on the top 10. So it should be pretty good, pretty relevant. And that was as of 2018. So yeah, it should be pretty relevant to what you would see today. So definitely stay tuned for that one. And if you want to catch up on the series, maybe you just jumped in here or somewhere in the middle, yeah, go ahead and check out, these cryptocurrency and security videos. The last, several of them, last 9 that I've done have been on different Ethereum or Solidity, I should say, smart contract vulnerabilities. A lot of the common ones came up. We already did videos on them. Yeah, so check those out. Be sure to subscribe, hit the like button, and I will see you guys right over in those videos. Thanks for watching.